Question 14, part A. In the diagram, A, B, C, D is a rhombus. That means all the sides are the same in length. EDC is parallel to AB, and BC is parallel to the x-axis. Find the length of AB, and part 2, find the corners of C. Well, length of AB is just a simple distance formula. So AB is equal to the square root of, that'll be 3 take away 0 all squared plus 8 take away 4 all squared, and that gives me square root of 9 plus 16, which is square root of 25, which is 5. So AB is a length of 5. If AB's got a length of 5, this means BC must have a length of 5. So the corners of C, because this is parallel, this makes it 3 plus 5, 8. 8. The coordinates of C. It's 8, 8. Right. Moving up. It says, show that the equation of EC, this one here, is equal to 4x minus 3 minus 8 equals 0. Well, we know what first of all, we work out this gradient here. We know this is the point 88. And we know the gradient of this one. So the gradient is equal to the difference in the y values. That's 8 take away 4 over 3 take away 0, which is 4/3. So this is parallel to this. So we use y minus y1 equals m outside of x minus x1. So y minus 8 using C equals 4/3 outside of x minus 8. So 3y minus 24 equals 4x minus 32. So taking this y across, we get 4x minus 3y. Taking that across, we get minus 8, which is what we asked to show. Okay, now show that AC is perpendicular to BD. Okay, let's have a look at the gradients of AC and BD. So the gradient of AC is equal to 8 take away 4 over 8 take away 0, which is 4 on 8, which is a half. Now the gradient of BD is equal to, now we need to find the coordinates of D. So similarly, if that's 5 there, the coordinates of this one will be 5, 4. So BD, the gradient is going to be using 8, so that's 8 take away 4 over 3 take away 5, and that gives me 4 over negative 2, which is negative 2. Now a half times negative 2 is negative 1, so AC must be perpendicular to BD. The area of the trapezium ABCD, this one here, well, that's composed of this one up here and the triangle. So the area of the rhombus, first up, will be area 1, will be equal to the base, which is 5, times the height. Now the height is at this difference here, which is just 4, which is 20. Now the area 2 of this one is a half times the 5, half the base times this height here, and we need to find the coordinates of E. Now to do that, we can just rearrange this equation here and work out the intercept. So now we'll have 3y is equal to 4x minus 8. So y equals 4/3 x minus 8 on 3, and that's the y-intercept. So this distance here will be, call that 8/3, or it's really 2 2/3, isn't it? and that distance there is 4. So that total height is going to be 6 2/3. 6 2/3, which is going to be 1820 on 3 times 20 on 3. And of course, that goes out with that, making it 10, which is 50 over 3. So the total area, now 3 into 50, it's going to give me 1, 2 over, that's going to give me 16 2/3. So the total area of the trapezium is the combination of these two, which is 36 2/3 units squared. Alright, last one. Find the not the last one. Find the distance between the parallel lines. 5x plus 12y minus 5 equals 0 and 5x plus 12y plus 8 equals 0. So what we'll do, we'll locate a point on one of the lines. So on this one here, I'll let y equal 0. When I do that, I get 5x equals 5, x equals 1. So the point 1, 0 lies on this line. So I want to find the perpendicular distance from this to this line here. So we're going to say that distance is equal to, now it'll be 5 times 1 plus 12 times 0 plus 8 all over the square root of 25 plus 144. And that's 169, which is the square root of which is 13. And on the top line, we're going to get 5 plus 8, which is also equals 13. So it's 13 over 13, which is just 1. Okay, and finally, we have to sketch the region bounded by the inequalities. X plus y is less than or equal to 1, y minus x is less than or equal to 1, x plus y is greater than or equal to 1, and minus 1, and y minus x is greater than or equal to minus 1. Okay, let's draw a couple of axes up here. Okay, this particular one here, right, when you draw the straight line, that's just this line here, and the region will be all points going that way. Drawing this one, so that goes that way. This is 1 here, and this is 1. This is minus 1, and it's that area there. Drawing this one, that goes from there to there, and it's all bits in here. That's minus 1. And finally, that one, you can just simply test points as I'm doing this. That one, it's all that. So it's just this tilted over square. The actual, another way of representing all that is very neat. All you have to do is this one. X, that's x, absolute value of x plus the absolute value of y is less than or equal to 1. Then simply remove all these. That'll be the first one is just simply x plus y is less than or equal to 1, and then making it, putting a negative on this, positive on that one, and so on. So that's, you can see it's very similar to the circle, isn't it? You've got x squared plus y squared less than or equal to 1 is the circle.